Hello everybody, I'm Alex from Singlet, and in this video I would like to show you our latest DevOps contribution to the pipeline foundation for the project Notepads. Notepads is a modern lightweight text editor with a minimalist design, and I encourage you to check it out. I personally have been using it for almost half a year and I've really enjoyed it. Our contribution to Notepads is comprised of several DevOps pieces. The first one is Dependabot. Dependabot is a security and versioning dependency scanner, which also creates pull requests whenever it finds an update. To enable the dependency version scanner, which is separate from the dependency security scanner, we created this dependabot.yaml, which is a configuration file where you declare all the project's dependency sources. In this case, we first added a single GitHub Actions ecosystem declaration to scan all workflow files and search for action updates. Then we added two NuGet ecosystem declarations to scan for .NET dependency updates. The second is CodeQL. CodeQL is an open source code scanning tool for discovering vulnerabilities across a code base. To enable CodeQL, we created the CodeQL analysis pipeline. It triggers on every push commit, pull request, and on a cron schedule of every day at 8 AM UTC. This pipeline consists of only one job, analyze, which runs on Windows latest, a keyword currently referencing Windows Server 2019. Uses a single build configuration, added a strategy matrix simply for convenience if more need to be added, and has several environment variables for values reused in the job. First, we clone the repo with the checkout action. Then we increase the page file size a little bit, because some projects have a huge code base and CodeQL requires more resources to execute flawlessly. Next, we install msbuild and restore the project's dependencies. Then CodeQL is initialized, and in the next step, we build the application. At the end, the CodeQL scan is run, which after completion first creates a commit or pull request check to show a summary of the scan, and then lists all the results in the security tab of the repo. Last, but definitely not least, is the main CI/CD pipeline, which of course we named Notepads CI/CD pipeline. We decided to trigger the pipeline on push commits, pull requests, and the workflow dispatch event, which is a way of allowing the pipeline to be executed manually at any time. Then we go on with the jobs, of which there are two: continuous integration and continuous deployment. The first one is the CI job, which runs on Windows latest. On the next line, you see a strategy matrix for the build configuration of the project, with a single value similar to the CodeQL pipeline. Next, we added several outputs of the continuous integration job that are needed by the continuous deployment job, and we also added two environment variables for values reused multiple times in the current job. Now we enter the tasks or steps, as they're called in GitHub Actions, of the CI job. First one is just a small script that handles conditional statements so they will be easier to maintain and read. Next, you can see a representation of how the conditional statements look like as handled by the previous step. This step would execute on any trigger but on pull request. The step itself simply installs Java 11 because it is required by a step down the pipeline. The next step installs .NET Core, but this was a mistake, and we communicated with the owner that the step is unnecessary since, of course, Windows runners have all .NET Core versions pre-installed. Next, we install msbuild. Then, we clone the repo with the checkout action. As we need to perform some authenticated Git actions further down the pipeline, we added the token property and gave it secrets.githubtoken, which is an automatically generated personal access token for each run of the pipeline with a certain amount of permissions. The next step is a simple script to retrieve the version number from the package apex manifest. And in the step after it, we retrieve the latest GitHub tag from the remote repo. Then we compare the two, and if the package apex manifest version number is different from the latest GitHub tag, we push it as the new GitHub tag. The next several steps initialize the SonarQL scanner. First, some caching is set up. Then the scanner is installed and initialized with some authentication. Next, since the build step generates packages, we added this step that creates the PFX key for the signing of those packages. First, the owner of the project converts their PFX into base64 locally and adds that code as a GitHub secret. The script in this step takes the package certificate base64 secret, converts it from base64, and generates a PFX file. This way, the key would live only during the execution of the pipeline, and no one else would have access to it. The next two steps restore the project's dependencies, build the project, generate the packages, and sign them with the previously created key. Next, the results of the SonarCloud scan are sent to the owner's SonarCloud account. And as the last step of the CI job, we upload the build output as pipeline artifacts. As we wrapped the continuous integration, let's now jump in the continuous deployment. The CD job is executed if several conditions are fulfilled, including if the CI job has completed successfully. The job runs again on Windows latest, and we added two environment variables to be used inside the job. The first step is again a git clone of the repository. This is done because each job in the pipeline is its own instance. Next, again because this job is a new instance, any resource generated by a previous job needs to be downloaded to be used. So the build output we uploaded as pipeline artifacts in the end of the previous job, now we download to use in this one. The next step automatically creates a GitHub release and populates it with information like new tag, release name, and so on. Next, we upload the MSIX bundle as an asset to the GitHub release created by the previous step. The last step in the CD job automatically creates a submission for the app in the Microsoft Partner Center, populates it with information from the previous submission, uploads the new package created by this pipeline, and submits it to the Windows Store. Here on the last line, as in the Dependabot and CodeQL files as well, you can see that this pipeline was built with love by the Pipeline Foundation. After the merge of the PR and some communication with the owner about an automated GitHub tagging, we submitted another PR with two major changes, which are the following two steps. First, we replaced the three steps that handled the versioning in the previous iteration of the pipeline with a single action which automatically generates and pushes a new GitHub tag if it detects a push commit with a semantic version label like perf, feed, fix, etc. in the commit message. The other step we added automatically updates the package apex manifest with the new version generated by the previous step. For all the pieces in the contribution, we have written an extensive documentation. Thanks for watching. If you have any thoughts about this video, please let us know in the comments and feel free to like, subscribe and strike the bell if you'd like to hear more from us. If you need assistance with DevOps implementation in your open source project, check out the description of this video where you will find links to the Pipeline Foundation projects board and onboarding application submission. We are at your disposal. Until next time, stay safe and aspire to DevOps.